Okay, this video is about local maxima and minima. So in the previous video I talked about absolute maxima and minima. This time it's local maxima or minima. So let's look at a definition. The function f is said to have a local maximum value at C if there exists an open interval containing C on which f is defined such that f of c is greater than or equal to f of x for all x in the interval. And there is an analogous definition of a local minimum value just by replacing greater than or equal to with less than or equal to. So let's look at some examples. Let's say A is here and B is here, and you have this function like this. Right. Now, let's say that C is this x value, right? Then this function, okay, this function f has a local maximum at x equals c. Because, right, if you look at the definition, it says that there's a local maximum if there is an open interval containing c on which f is defined such that f of c is greater than or equal to f of x for all x in the interval. Well, there is. If you just look at this interval from a to b, right, f of c is the biggest y value on that interval. So we say that f has a local maximum at c, and local maximum value at c. And the maximum value is f of c. Okay. And what about local minimum? Well, it's not at c, right? Okay. There is no local minimum. Now, we don't know what's going on to the left of a, so we can't guarantee that the function has a local minimum at a. Okay. Another example is this is a, and this is b, and this is c, something like this. Right? Again, f has a local maximum at c because in some interval containing c, so the interval from a to b, f of c is the biggest y value out of all the possible y values. On the other hand, if you had something like this, then there is a local minimum at c. So for this function, there's a local minimum at at C, because at some interval slightly to the left and slightly to the right, this value, f of C, is the smallest y value that's achieved. And similarly, if you had C here and the function was like that, then on some interval slightly to the left of C, slightly to the right of C, right? This y value, f of C, is the smallest of all the y values on the interval from A to B. So this also has local minimum at C. And if the function has either a local maximum or a local minimum, value at C, then f is said to have a local extremum at C. So local extremum means either local max or local min. Okay, and the same thing that we saw for a constant function with absolute maximum applies here. So let's say that you had a function f of x equals 3. So here's the x-axis, and here's C, and here's 3. F of x equals 3. Well, this function does have a local maximum and local minimum. At C, because there is an interval, in fact for every interval, but all we need is there is some interval for which the values of the value of f of C, which is 3, is bigger than or equal to all the other y values in this interval. Right? It's not bigger than all the y values, but it's bigger than or equal to all the other y values. And by the same reasoning, the function has a local minimum at C, because f of C is less than or equal to all the y values in this interval, in some interval around C. Okay, let's look at an example comparing absolute maxima and local maxima and minima. So let's say that you had this function, kind of make it kind of big, like this. And it goes through 0, 1, and then it goes up like this, and then it goes down to 2, 2, and then it goes up to 4, to 3, 5, and then it goes to 4, 4, and then to 5, 3, and then it stops, and then it continues at 5, 1 to a 7, 0. Okay. So you have this function. And the question is, what are the absolute maxima and minima on So just looking at the interval, the closed interval from 1 to 7. Is there an absolute maximum value? And if so, where is it? I think the absolute maximum value is 5 at x equals 3. Right? It's the biggest y value and it is achieved. What about the absolute minimum? Oh, it's undefined at 7. Okay. So, sorry, we want a half of an interval. An absolute minimum value of the function on this interval. Well, there's none, right? Because the y values are all positive and 0 is not attained. If this hole at the end were filled in, then we would say that the absolute minimum value is 0 at x equals 7. But in this case, there is no absolute minimum. Okay, local maximum value. What are the local maximum values? Well, let's look at we have this value here, right? When you look at the immediate vicinity of x equals 3, slightly to the left or slightly to the right, 5 is actually bigger than all the other y values. So there's a local maximum of 5 at x equals 3. What about x equals 4? Is there a local maximum here? No, because slightly to the right of 4, the y values are smaller than y equals 4. Okay, what about here? No, again, because slightly to the left of x equals 5, the y values are bigger. What about here? Well, here the y value is actually 2, and there is an interval, right? If you just look slightly to the left and slightly to the right, all the y values are up here. So they're all bigger than 2. So actually there is a local minimum value of 2 at x equals 1. Okay, what about here at x equals 2? That is a local minimum value. Because in the immediate vicinity to the left and to the right, the y value 2 is less than or equal to all the other y values in that interval. Okay, what about this one? Is this a local minimum or a local maximum? No, because this one's sort of tricky, but if you look at the technical definition, there needed to be an open interval containing C on which f is defined. And here f is not defined to the left of 0. So there is neither a local, so the endpoints, if the function is only defined on the endpoints, then we don't include those as local max or local mins. Any other local maxima? No. So I hope that this was a good review of local maxima and minima. Let's just do one more example. Let's say that you had this piece piecewise function, 25 minus x squared. If x is between negative 5 and 0, and 4x minus 3 if x is between 0 and 5. And I'll give you a graph just like this. When you plug in 0, you get 5, right? It's the parabola, but it's undefined. It's undefined there. Okay, so you have this, and this is 5 comma. Oh, sorry, this is 25, right? And this is 5 comma 17. There's 17. So is there an absolute maximum value? No, it's not attained. There's no absolute maximum. What about absolute minimum? There is an absolute minimum value of negative 3 down here. That's the smallest y value, and it's attained. What about any local maxima? No, there aren't any. There's no local maximum. If you look at it, we don't include the endpoints, and if you look at any other point, either slightly to the left or slightly to the right, there's going to be values that are bigger. And what about local minima? Yes, negative 3 is the local minimum value. Because if you just look slightly to the left and slightly to the right, negative 3 is the smallest y value. Okay, I hope this gives you a good idea of absolute maxima, local maxima, and minima, and the difference, and that you get some practice to quickly see what the absolute maximums are and local maximums.